In order to calculate the correlation coefficient, it is necessary to first obtain the covariance. The covariance is in itself a measure of the strength of the relationship between two variables, but it doesn't have the advantage of the correlation of coefficient that it is a standardized measure. That means that the covariance will be useful only to determine the relationship between the two variables that we are analyzing, but we cannot use that value to compare to relationship between other variables. Let's see how we calculate the covariance. Here we've got a regression in red and the observations in orange, and the mean of x in yellow, the mean of y in green. The covariance is also an average. As you can see, when we divide by n minus 1, it's an average of some sum of things. What is the sum of? Well, it is the sum of the product of some values related to variable x and some values related to variable y. What are those values? Simply the distance between the value and the mean. So we've got a indicated in white dash, 3 observations, 3 orange dots, and the distance between them and x, and the distance between them and y. Sorry, between them and the mean of x, and between them and the mean of y. So that distance, that value that indicates the distance, is multiplied by the corresponding value of the distance with the other variable. Now, we can divide the space into 4 quadrants. In the top right one, we've got the values of the difference will be positive for y and positive for x. So that means when we do any of these orange dots, we subtract the mean of y, it will be a positive value. When we subtract the mean of x, it will also be a positive value. So we are multiplying 2 positive values. On the bottom left corner, we've got 2 negative values. So when we subtract any of these orange dots, the mean of y from any of the orange dots, we obtain a negative value. And when we subtract the mean of x from any of these orange dots, we also get a negative value. Now, when we multiply these 2 negative values, we get a positive value. So all the dots on the right top and left bottom quadrants the multiplication of those difference values will always give a positive value. So you can see here that most dots are either on the top right or in the bottom left quadrants. So basically, this relationship, when we add all these positive values, it will be a positive relationship. There is only one clear value that is that the multiplication will be negative. There is one orange dot in the top left quadrant, and basically that value, when you subtract the mean of y, you obtain a positive value. But when you subtract the mean of x, you obtain a negative value. So the multiplication of these 2 values will be negative, and this will decrease a little bit the positive relationship that we have in the other values. So because it's massively in favor of positive values, this correlation will be a positive correlation. In this example, we've got a negative correlation because we've got more dots in the top left and bottom right quadrants, and so when we subtract the corresponding means and multiply those values, then we will obtain negative values. And there are less dots in the top right and the bottom left quadrants, which will give positive values. But it's not as clear as in the previous case, so this correlation will be negative, but the value of the correlation will be much lower. And here it is, finally, the Pearson's product moment correlation coefficient R. How do you calculate it? Okay, so we have two versions. One is in a population. So if we are considering a population of values, then the Pearson's product moment correlation coefficient is called ρ. It uses the Greek letter ρ, and it's calculated by obtaining first the covariance of x and y, and then divided by the standard deviation of x times the standard deviation of y. What about in the sample? Same thing, except that would be the covariance of the sample and the standard deviation of x and y in the sample, which I've seen how we calculate the covariance. Now, the standard deviation of x and the standard deviation of y we also seen before. We have to just subtract the mean from all the values, add all those values, and then divide by n minus 1, and finally obtaining the square root. We do the same with x values and y values. So that's the way we calculate the Pearson's product moment correlation coefficient. When we divide by the product of the two standard deviations, the values will be, the possible values will be between -1 and +1. And that applies to any type of variable that have any scale of measurement. Sorry, it just has to be a numeric scale of measurement, but could have any range of possible values.